For this one, I want to do the vertex opposite of b over 2a. So I do 2 over 2 times 1, which is 2 over 2, which is 1. And then I have to plug that back in. That's just the x value for my vertex. So I do 1 squared minus 2 times 1 minus 8. That's 1 minus 2 minus 8, which is a negative 9. Axis symmetry is x equals the x value from the vertex. The y-intercept, I plug a 0 in for x. It's also my constant term. If I plug a 0 in there, I get a negative 8 out. The x-intercept, I plug a 0 in for y, which essentially means I'm going to have x squared minus 2x minus 8 equals 0. And now I just have to solve this. This factors into an x minus 4 and an x plus 2. I set each factor equal to 0, so I get x equals 4 and x equals a negative 2, which means I have these two ordered pairs, the 4, 0, and the negative 2, 0. And now maximum or minimum, I look at the a value. The a value here is 1, which means this thing opens up, which means my vertex is the bottom. It's a minimum. And I'm going to go by 2's over here on my graph. So let's see, I've got 1, negative 9 is right here. The axis of symmetry is right here. The y-intercept at negative 8 is right here. I can reflect that point over here. I've got the positive 4 is right here. The negative 2 is back here. And that's enough information to graph this thing. It's just a parabola that opens up and has all of those values that I just found. And that's it. This one, I want to graph this guy, so I do the vertex, and the vertex is right here. It's these guys. That's the 1, 3. So I go 1, 3, and I plot that point right here. And the a value is negative, so it opens down. It's going to be stretched vertically. So instead of going down 1 over 1, I go down 2 over 1. So it looks like this. And again, this is the absolute value, so it's going to be a V shape. And remember, absolute value is a V shape as opposed to a quadratic, which is a U shape, a parabola. This one, the vertex is a negative 2, negative 4. So I go negative 2, negative 4 is right here. This one's going to open up, and it's going to have my standard width of up 1 over 1. That is terrible looking. Let me try again. Okay, so I get a V that looks like this. This last one, there's two ways I can approach this. You can solve this for y and put it in slope-intercept form and then plot the y-intercept and then go and follow the slope. Or we can just put zeros in here. If I plug a 0 in for x, essentially I have negative 3y equals 6, which means y equals a negative 2. And then if I plug a 0 in for y, I essentially have a 2x equals 6, which means x equals 3. And I can just plot the x and the y-intercept. The y-intercept is a negative 2. The x-intercept is a positive 3. And that is plenty of information to graph this thing. And that's it. For these, when we're looking at each of these things, we know that these are rational functions. This one is going to have a vertical asymptote at x equals a negative 1. And I know that because I get a restriction of x cannot equal negative 1 in my denominator, and it's a restriction that doesn't cancel out. It's also going to have a horizontal asymptote at y equals 0. And that's because the degree of the denominator is larger. And that's essentially enough information to narrow this thing down. The only one that has those two x-intercepts, and then I can plug in some values to check this, is letter B. So this one, number 50, is letter B, and that's it. Okay. Number 51, I do the same thing. I can tell that there's a vertical asymptote at x equals a negative 3, again, because there's a domain restriction that x cannot equal a negative 3, and it doesn't get canceled out. There's also a horizontal asymptote for this one at y equals a positive 2. And I know that because the degrees are the same, so I divide these leading coefficients. 2 divided by 1 is 2. And again, that's enough information to narrow this thing down. It's got to be letter C, because that's the only one with the proper vertical and horizontal asymptotes. I can also plug some values in to check it. And then this last one, in terms of vertical asymptotes, I'm going to have one at x equals a -2. And that's going to happen because, again, there's a domain restriction here that's not going to get canceled out. This one has an oblique asymptote because the degree of the numerator is larger, and I can find that by doing synthetic division. So when I do that, I get a 1, I multiply, I add straight down, I multiply, I add straight down. And what happens here is I essentially ignore this piece, I ignore the remainder. I just look at this and see that this interprets into an x plus 1. Well, that's y equals x plus 1. That's the equation of a diagonal line, which is letter A, and that's what's being shown here. So that's letter A. That's it. Okay, so be aware of how you find the vertical asymptotes, horizontal asymptotes, oblique asymptotes, and then just use some extra values to narrow this thing down. Okay? Hope this was helpful, and good luck on your test.